Good morning, everybody. Thank you for coming. Hope you guys are enjoying the beginning of Build so far. My name is Michael, and I am a program manager on the Office Extensibility team. So today, you're going to learn all about function extensibility. I have two features that I want to share with you, and we're going to go through what's happening now in the preview, what's coming in the future for those features, and you'll see a whole bunch of demos along the way. We're going to start out giving you the high-level overview, and then we're going to get into a whole bunch of detailed, interesting points about each of those features. So here we go. Whoops. Stay on number 5 here. Let's talk about functions, function extensibility inside Excel. So up on the screen there, that is the sum function, which I hope you all know and love. Functions, of course, and using them to create formulas in Excel, that's really the atomic unit of constructing models inside Excel. It's a super important feature, and there are billions of these functions executed every single day inside Excel. So having a way to extend that point of user interaction is going to be super important for anyone who wants to extend Excel's features in general, right? That is the place to be. If you can attach yourself to that sum endpoint to create whatever new function you wish, you're going to be successful. But I don't need to convince you, I think. I found this. These are just some clippings of different examples online. Folks are asking us, and have been asking us for a long time, for ways to extend functions inside Excel, not just on the desktop, but across all the platforms that we have. Function extensibility is really important for people. The examples there are mostly from Stack Overflow, I think, but I've also taken examples from the Office User Voice and other forums and pages around the web. So when I think about custom functions, there are a couple different features that we know are really critical to help you extend Excel's functions, to help you extend the formulas inside Excel. Here's what we think they are. The first one I already mentioned. These functions need to be able to run no matter what the platform is. So of course, we have the existing technology called UDFs, user-defined functions. Those run in the desktop. But when we want to extend functions in the modern age, we need these to work, of course, across all platforms, right? Not just the desktop, but also on your mobile devices and in your browser. Right? Extending Excel formulas, that needs to work everywhere, no matter where that user is in Excel, obviously. The second point, super important, running quickly. These functions need to execute immediately. They need to feel responsive. And I'm going to go into a bunch more detail there later in the talk. I actually have some really exciting news for everyone about where we are in terms of speed and how quickly these functions can run. The third one there is looking and feeling like native functions in Excel. Also extremely important. What does that mean? Well, like I said, that billions of times that users are running these daily. It's such a huge surface area, and what's the reason? It's because they're comfortable with it. Everyone understands equals sum. They can look up formulas and functions online to find the useful ones that they need for their particular task that they have. Excel users are familiar with it, they understand it, and for you to extend that function point, it needs to feel just the same as someone typing in equals sum. That's how easy you want to make your extensibility for Excel formulas. The next point I have here is that they're shipped by developers as part of an add-in. So many of you know about the new web model of extensibility that we have, where you can ship an add-in. It runs JavaScript, HTML, other web technologies, and those can be deployed across organizations and to App Source, which is a public store that anyone can get. We think it's super important that custom functions participate in that model, that as a developer, it's just as easy to extend Excel formulas as any other surface inside Excel or, in fact, elsewhere in Office. Now, some of you might look at that and wonder, well, there's actually a different use case as well, not just for developers to ship the function extensibility as part of an add-in, but for users to make their own, kind of hack around with the functions and code that you want to build yourself, not necessarily to ship this thing publicly. And that's something that we're exploring and thinking about too. But for now, the features that I'm introducing, what I'm explaining for this presentation, is all about how you get these functions in an add-in, whether you're at ISV or you want to create functions just to use internally at your organization. Okay, this is the case for how do you create functions if you're a developer. The next point here is making web service calls. So these days, a lot of the use cases that I've heard about from customers, it's all about bringing in data from the web. Okay, whether it's you have a stock price on the internet that you need to bring in, cryptocurrency price, you want to, maybe there's a database that you have hooked up, you have enterprise-specific data, you want to pull that in so that it makes it super easy for the users, they don't have to go configure a whole bunch of other services and flows to get the data. No, the user just types something, brings in data from the web. That's the key scenario that we've heard from people. And so we want to make that first class and really easy to do with custom functions. The next point there is kind of the opposite point. So at the same time, if they don't depend on the web, then we don't need to tie ourselves to that internet connection, right? If you're on a plane, if you're somewhere where you don't have internet access, the functions still need to run offline. One of the core things that we think about in Excel is that recalculation of all your formulas always needs to just work. It's critical for Excel. And so that's why we have the capability for the custom functions to run offline. And I'll talk a little bit more about that later in the presentation. The last point I have here is kind of grayed out a little. It's talking about when the work is unattended. What does unattended mean? This means that there isn't actually a user sitting there in front of Excel and they can see the spreadsheet. Instead, the spreadsheet is just up in the cloud. It's in OneDrive, for example, and perhaps you have some other application, like an iPad app or something else, that is making a graph API call to use Excel as its back end, or just as the spreadsheet that's linked. So for example, you have a form system set up on your iPad. You enter a maintenance request there. It sends that over into Excel. Well, guess what? If you have custom function extensibility in Excel, that needs to run without anyone even looking or thinking about that particular spreadsheet at that moment. And the reason it's grayed out is because that's not something we have yet, but it's something that we will have in the future. I talked to you a little bit about add-ins and how custom functions are just part of an add-in. And this slide will help me explain that a little bit more. I'm showing the different pieces that exist in add-ins today. Okay, so when you build an add-in, you can have a ribbon. You can have buttons on that ribbon, all configured as part of the add-in that you build. You can have other UI surfaces. You can put together a task pane with UI and HTML. And you can have a dialog, for example, that shows up on that page. But what we're adding to that is the ability to show custom functions, to include custom functions as well in that add-in. And it's just a natural part of the package. So if you want your users to have that function extensibility, you can ship just the functions as part of an add-in alone. Or you could also include a ribbon button and task pane UI, perhaps other information to help your users use those new functions that you created, or just other related functionality. You can pick and choose whichever pieces of add-on extensibility you need most. One of the best things about that new add-in platform is how easy deployment is. So previously, it wasn't like this, but the news story is fantastic. All you need to do to deploy your add-in within an organization is go to the admin portal and upload it there. Immediately gets deployed to anyone who you choose at your organization, right? So you can configure particular groups if you wish. Say, I want to make this available for the finance organization, okay? Or no, I want to make it available for these 3 specific people. Any combinations that you wish. It's super flexible. It's really easy. You do that, and then next time the user opens Excel, they'll just automatically have that functionality available to them. This is way easier than deployment was in the past. So I just mentioned a couple slides back that these functions need to be able to run unattended. And that might trigger something in your mind. You might ask me, where are these functions actually running? That's a really important question. And the answer is there's a spectrum. Okay, when you think about it, there are 2 opposing goals that we could need when we're thinking about how to run custom functions. On the one hand, it's fantastic to be able to run the functions client-side. I have a couple reasons up there why you can see on the left-hand side. First of all, it's cheap to do, right? There's no additional cost for the user if they're just running them on their machine. I mentioned working offline, of course, really important. And there's no delay from the network either. But on the other hand, a lot of cases, you might want to run your functions on the server too. I mentioned the reasons why there. Scalability is the #1 reason, right? If you have super heavy processing, it could be something that could take years to finish on some regular user's laptop. But you might want to take advantage of the cloud, run this thing across arrays of GPUs, and then be done with the calculation in seconds, perhaps. And the second point is the reason why we want to run on a server, run on the cloud, is that it doesn't depend on a person. This is about unattended functions, right? If there's there are many cases, like I said, where there's no user there to run them at all, and they just need to work. And the only way for that to happen, if there's no user, is of course for them to run on the server. So you're thinking, okay, well, which one did you choose? Are they running on the server? Are they running on the client? There are different use cases that kind of span them. Client side, we have something simple like you can imagine a math function, calculating whether a number is prime, right? Of course, makes sense usually to run that on the server. Maybe you have something that's running on the client, usually because someone's looking at the spreadsheet. Maybe they want to stream in data, but it's still getting information from the net, right? So that's still technically running client side, but maybe connecting to some external service, right? So it's a little farther to the right. And then another step to the right, okay, you have this unattended case. Perhaps I mentioned that maintenance request. Maybe you put in a phone number to that maintenance request, and there needs to be a function to automatically generate a city from that phone number and just plot that right into Excel. Okay, so that one, since it's unattended, definitely needs to run on the server. And then all the way to the right, of course, we have the machine learning case, right, where you have super intense computation that's happening in the cloud. You want to do something like have a large set of data. You need to analyze what the probability of fraud for each of those hundreds of thousands of rows are, stuff like that. Then you definitely want to be running in the cloud. So how do we attack this? Well, JavaScript custom functions is a set of features I'll talk about in a bunch of detail today. Those address, today, the left-hand side. That's not to say that it won't, in the future, address the whole spectrum. And we have plans to reach all the way from client side seamlessly to the server side just with JavaScript custom functions. But today, that's left-hand side of the screen, more related to client side. And how do we reach those folks all the way to the right who need a high-capacity execution and those capabilities? Well, we have another technology called Azure Machine Learning Functions, which are also just another type of custom functions. All the information that I've told you so far applies to both of these function types. And you can deploy them. You can use them in exactly the same ways. So those are the two technologies that I'm going to tell you about today. And first, let me start with JavaScript custom functions. I'm going to give you a little demo here. And that switch. Oh. I dismissed that notification. So some of you may know in the audience that I don't only work at Microsoft. I also moonlight as the analyst for the Contoso chocolate factory. Okay? This is a pretty tough job. I have quite a demanding boss. Boss wants to know at any given time a ton of information about the factory. Right? And so I, as the analyst, need to be able to tell the boss any of a whole bunch of different data points about what's happening. If there's a stoppage in the output, I need to understand exactly why. These are all really important questions for me to answer. And I depend on Excel. Excel is the lifeblood of this chocolate company. Okay? Because the chocolate needs to be made exactly. The recipes need to be perfect. It can't be burned. The quantities need to be completely perfect. And so for that, I have a spreadsheet set up. You can see I have some recipes. We produce two different products, the small truffles and the large truffles. You can see below. I've got a nice picture of truffle that someone has already started consuming. And each of those are made with two types of ingredients. Ganache, which is that stuff in the middle that you see, the delicious ooey gooey center, and the truffle chocolate itself in the truffle mixer. That is the outer layer here, the hard part that you bite into. And you can see that I also have the recipes for both of those ingredients here. So the ganache mix and the truffle mix themselves, they're both created from a combination of delicious cream and cocoa and also sugar, but just in different quantities. Okay? So what would really be great is if I could see at a glance how much of each of those stage 1 ingredients, the ganache mix and the truffle mix, I have in my machines at any given time. And to help me with that, I've connected scales. They're internet-connected scales to both of the mixers, the ganache mixer and also the truffle mixer. Both of them are connected to the web. And so they can stream data anywhere. And helpfully, the developer for Contoso Chocolate Factory has built me custom functions inside Excel for me to query those weights on my own. All I need to do is type in here equals Contoso. And immediately, I have a bunch of functions that the analyst that the developer has enabled for me. You know, I could even search another way, like I could enter weight here, and I could see the specific ones, the specific functions that are related to the weight that I'm interested in. Remember, I'm trying to calculate the number of kilograms of material inside that ganache mixer here. So I type that in, and then that gives me IntelliSense, essentially, in Excel, and shows me the two different functions that are available. You can see also has the description on there. It says here, returns the weight of a scale. And like other functions inside Excel, the IntelliSense is asking me to enter the parameters that I need. In this case, it's asking me for the ID of the scale that I'm interested in. And in this case, the ID is the name of the scale. It's the ganache mixer scale. And then I hit enter. It says getting data. while it's querying the server, and then returns back a value inside Excel. You can see 530.0 kilograms is the total mass of ganache mixer inside the factory. OK, great. Let me do the same thing. I can copy over for the truffle mixer. I don't need to type it again, of course, because Excel is so wonderful. It just automatically figures out that I'm referencing the truffle mixer in this cell, as you know. And there the value also comes back, 320 kilograms of truffle mixer. Sounds pretty good. Because the developers in the factory are very clever, they've also arranged to measure the output. So not only do we have scales for the ganache mixer and the truffle mixer, but we also have scales for the resulting small truffles and the resulting large truffles. So now I have a complete picture of what's happening inside my factory, how much of each ingredient is there, and what my total output is. Perfect. Boss is going to love that. Now, there's a lot of information here. I don't know if you guys in the audience can picture in your head what's happening exactly. I know it's a little bit tough for me just looking at the numbers on the screen. Right? Wouldn't it be nice if there was some visualization that could really show me in a clearer, easier way what's happening inside the factory? Well, thankfully there is. So some of you might have already noticed what I'm describing here is actually a multi-stage process, right? You go from the ingredients, the cream, the chocolate, the cocoa, the delicious ingredients, into the wonderful mixes of everything together, into finally the resulting product. And if you want to have that kind of data shown in a diagram, one great way to do it is called a Sankey diagram. But the thing is, Sankey diagrams are not one of the default Excel chart types. It's unfortunate, but what can we do about that? Oh, look, a tab called Custom Visuals inside Excel. Let me insert that Sankey diagram. And look at that. Now I have a beautiful visualization of all that data I showed you before. On the left-hand side, the ingredients. In the middle, the stage where I have the ganache mixer and the truffle mixer. And then finally, my output products on the right-hand side. And the gray flow indicators are showing me the amount of mass that goes from one stage to the next. Easy for me to see at a glance. Okay? This is a custom visual inside Excel. In just a minute, I'm going to tell you a bit more about custom visuals. But before I do that, you might also be asking yourselves, well, it's great that I have that kind of static image of what's happening inside the factory. But what would be even better is for me to see in real time exactly what's happening with all that information in the factory. And guess what? Custom functions can do that too. That's right, we have streaming functions that can bring in data continuously into Excel. And that is what I'm going to show you right now. You might have seen when I entered the wait function, there was also one called stream wait. And I'm going to do the exact same thing, but streaming it in. OK? Actually, before I do that, whoops. Let me reset this. Equals contoso.streamWait. And now the values are coming in a stream, continuously showing me the information. You can see there's some waste at the bottom, and resulting from the process. And as I'm watching this stream, I can see the data is coming in, updating the visualization in real time. But interestingly, look at that. The waste is growing. And the waste in the final product is growing really fast. Now look at that. Small truffles and large truffles, the output product is almost nothing. And I can see that's because the ganache mixer weight has shrunk. This is something I certainly could notice without a visualization. But the visualization is fantastic. Lets me and my boss immediately identify something is wrong there with the ganache mixer, because that's so small relative to what it was before. And so I can go investigate, find something like perhaps there's a leak or a spill that's happening inside that mixer. So let's talk a little bit more about that Sankey diagram and what it means, where it came from. Custom visuals are a way for you to extend Excel's existing visualization catalog. Okay, there's a whole world of possibilities. So many specific things people want to see inside Excel that they can't do with the wonderful but limited existing chart types. So you can see on the screen there a whole bunch of different possibilities, showing car manufacturer type visualizations, word clouds, floor plans, anything you could possibly imagine, those can be created as a custom visual. Okay? So the great thing is you can build these custom visuals with existing JavaScript libraries. D3 is a great example. You can create them completely specific to your needs with custom JavaScript if you'd like. And if you go look right now at AppSource, you'll see more than 150 are available for you to try and use today. You can use some of those existing ones. But regardless of which ones you pick, they can be deployed not only individually to folks who go to the store and download the ones that they're interested in, but they can also be deployed to enterprise. Just like an add-in, you can go to the Office 365 portal and set it up so that everyone in the organization has the custom visuals that they need. Right? If it's your floor plan custom visual, you can set it up so just the architecture department at your company has access to them. I've got an array here of ones that are available today in the examples that are available. You can see these ones. One of the ones is the Sankey diagram that I showed you. But there are many different categories of custom visuals that could be useful. Right? Not only could you show, you could have ones for visualizing text, like you see all the way on the right-hand side of the screen. Or you can have ones that are very similar to existing chart types inside Excel, like the bullet chart and the tornado chart as well. There's a lot more information about custom visuals that you can get at Build. There was a great session yesterday you can look up online, and later today we have 2 sessions that I highly encourage you to go check out. You can also sign up for updates at this link here. That way you'll get an email once there's more information for us to give you. Let me jump back to the demo. So I promised you I'd tell you about performance. What I showed you before are functions that go query the web. Functions like get weight and stream weight. There's an internet-connected device. And then that's going to bring in data to your spreadsheet. But what if it's that math type of function that I talked about before? It's very simple. Just needs a bunch of calculation locally. But that needs to be really fast. Why does it need to be fast? Well, you don't need to wait for a round trip. It doesn't need to go to the web to calculate its result. It's very simple. And so those should run lightning fast. In the Contoso chocolate factory, my boss is very particular about how he packs the chocolates inside the boxes that we sell. How is he particular about this? He doesn't want the folks who buy the chocolate boxes to be able to share equally the number of chocolates inside the box with their friends. Why not? Because then they have to buy another box. Oh, there's one left over. Who will we give this one to? Have to get another box. This is an interesting math problem that my boss has devised here. And those of you who remember your math might know that the way to make sure that no matter how many friends you have, you cannot split those chocolates equally is to sort the chocolates is to place the chocolates in prime numbers into their boxes. And so my boss has only certain allowable numbers of chocolates that he can have. You're not allowed to put 4 chocolates in a box. It's not a prime number. And so the developer has very helpfully enabled a function to generate some different primes that are acceptable to put the number of chocolates in that box. This function is called nth prime. All it does is generates a prime based on the input number. So the first prime, you may know, is 2. If I enter that here, that should yield 2. And you can see there was no getting data. There was no delay. It showed the result instantly. I can copy this down, just get the first 25 numbers. Boom. There's my first 25 primes in the spreadsheet. Say I want to have much larger boxes, ship this to a big organization, big company. Again, give them some very high primes. Let me change this to 100. Immediately, get the results back for the prime numbers from 100 through 125. This is all running JavaScript, but it's super fast. Okay? Not only that, I could show you some examples with even more data. Let's copy this over here. Whoops. And now I'm going to do the same thing, but for 100 functions run at the exact same time. Just creating some counting numbers here. So there's 100 different functions, 100 different integers, excuse me. And then, again, nth prime of this one here. No problem. Copy it over 5 columns. Or this is 125, I guess, not 100. And again, the nth primes for that set of data. What if I change this to 1,000? It gets difficult to look at that. Look how quickly that was. It gets very difficult to calculate primes as you go higher in your numbers. I could check the 2,000th prime and the next 100 of them. All calculated very quickly inside Excel. So how are we doing this? This is actually taking advantage of Excel's multi-threaded recalculation abilities. All those functions, they're being calculated in parallel. And the parallelization, of course, depends on the threading capabilities of the chip you have on the machine. So your performance will vary depending on what you have. But typically, certainly possible to multi-thread a lot of your functions at the same time. How have we done this? Contrary to the existing framework used for Office add-ins where they're running in a separate process, what I'm actually showing is JavaScript running within the Excel process. We have integrated the Chakra Core runtime. That is the same runtime for JavaScript that's used inside Edge right into Excel in the same process so that everything runs locally and super fast. If I switch back to the presentation, I'm actually sharing some of our performance numbers. So on the far left-hand side is XLL and VBA. And this is showing a logarithmic scale. There are a couple of different scenarios that we've tested. First is the long-running function. I've calculating the 1,000th prime in the light-colored bars. And then I'm also calculating in the dark-colored bars a much shorter function, just returning the amount of a mortgage payment, which is essentially one line of code. And you can see performance is very different for both of those, of course. By the way, each of these numbers, this is for 1,000 of them calculated, 1,000 instances of each function calculated simultaneously. Okay? So for example, in VBA, it takes more than 10,000 milliseconds, or 10 seconds, to calculate 100 instances of the find the 1,000th prime number. 1,000 instances of find the 1,000th prime number, whereas it takes more than 10 milliseconds to calculate 1,000 instances of calculating the mortgage payment. And what you'll see is that is very high, in other words, poor performance numbers comparatively, if you wanted to calculate these in a web control process. That's the two high bars in the middle. But we have improved the performance by orders of magnitude by integrating Chakra Core. You could see in the pink bars on the right-hand side, both light and dark, not only are we far beating the performance of the web control process because it doesn't need to cross the process boundary, but we're even exceeding the performance of VBA inside Excel with JavaScript and coming very close to the performance of XLL add-ins. So I'm really excited to show you these numbers, and I want you guys to all try out the performance that we have, give us your feedback, and let us know what you think. I mentioned that we're in preview for custom functions, and I'll just plug the URL of that again, aka.ms/custom functions. You can try it out right now. It's been available in preview for 6 months now. And starting today, you can try out all the new features that I've talked about. What are those new features? So I'm happy to announce, starting today, they're not only available for Excel desktop, you can also run these functions on Excel for Mac today and Excel Online today. So please try that out. Let us know what you think. Give us your feedback. Also, I already announced, previously you could only run those asynchronous functions in a separate process. Well, like I said, today you have that option for the asynchronous functions, and you also can create those super fast synchronous functions inside Excel. You can try that out today. Because it's synchronous, those ones will work in Mac and Windows, both. And the final update that I have for you today is about registration. So previously, registration was something slower. You had to call an API at the beginning of the session in order to get those functions registered inside Excel. That is no longer the case. Now, I'm going to show you how it works. It's all configured automatically. With a declarative set of code, you just specify the JSON that you need. And Excel, without spinning up any JavaScript process, can immediately register for all the functions that you need. It's much faster. It's much better. So I have shown you some demos of my own. And those are great. But as you know, they're invented. They're a little fake. And so I'm really pleased to have a real customer showing you a demo on stage today. Hanha is a London-based IoT innovator. They design and manufacture their own hardware platform. So please welcome Adrian Ferreira from Hanha.
So my name is Adrian, and I'm an embedded software engineer at Hanha. So the product I'll be presenting. Check. Sorry about that. So my name is Adrian, and I'm an embedded software engineer at Hanha. So the product I'll be presenting you today is called Symbiza. So Symbiza is both an Internet of Things device and a connectivity solution. The device itself is a sensor array. It measures and captures data from its environment. So we have multiple sensors on board. We have sensors that measure humidity, temperature, pressure. We also have an accelerometer and a gyroscope, as well as a GPS chip to track location. So as soon as I press the button, the data will start to flow, and it will be done securely through the Hanha mobile network. So when this data is on our backend, you can access it in a variety of ways. But we will focus for today on the Excel stream function we developed for Excel, since it has been the way for us to target the most people with a relative low development effort. So I press the button, so now the data is flowing to our backend. And as I said, we developed our own custom functions. So for example, if I click in the cell, start to type my function, so simbiza.stream. So we can see here all the different variables we have. We have the one that are related to the GPS, pressure, etc. Let's focus on the lights, the ambient light expressed in lux. So I just type lights, and then I give as a reference the device ID. So now, as soon as I pressed enter, Excel will now periodically call my own JavaScript callback function for this particular piece of data. And in this callback function, what we do is that we send some AJAX request to our backend to have the last update for this particular variable. So as soon as the backend replies, we just have the last value, and then we return it, and then Excel will update the cell for us. So once this facility is up and running, you can build any service, Excel service you want on top of it, because for Excel it's seen as a normal cell. So that's what we did, and with the help of the Office 365 engineering team, we put together an example of a dashboard. So you have here some visualizations. One is for the lights, we have temperature, we have the orientation of the device, as well as the state of charge for the battery. So I decided, for example, to use my Simbiza device as an asset tracker. And let's say that a friend of mine sent me an expensive bottle of wine from Paris and put my Simbiza device inside of the parcel. Not only I can track it with the GPS coordinates, but as well I can see, for example, if the light changes, it means that the box has been opened. Temperature, really important for wine as well, and the orientation of the box. So this device is inside of the box, and as I will change the orientation of the device, I should see, as soon as the ping will arrive to the backend, we will see basically the visualization update. So let's now try, for example, opening the box. Okay. So now the level of lights should change, pointing to the lights. And as soon as, again, the lights, the ping will be sent to the backend, the visualization will update as well. All right. So we as well developed a side panel. So this side panel is for the user to track all the different devices he has. So you can see there, and if you click here, you can see the different values you are currently streaming. So why Excel? Well, Excel has a customer base of millions of people that are already familiar with its capabilities. So for us, it's the guarantee that most of our customers will already know how to visualize, analyze, and make sense of the data flow coming from the Simbiza device into Excel. Excel is cross-platform, Excel is globally distributed, and this comes at no development bias, really. As I mentioned, the Excel also uses standard technologies like AJAX, AJAX request, there are jQuery, AngularJS, and this has allowed us to have a really seamless integration with the current architecture we had. So at HANA, we really want to make deploying IoT solutions easier and faster. And now we think that if you know how to run an Excel spreadsheet, you're ready to go. And with the partnership now we have with Microsoft and Element 14, we think that this IoT is open to everyone. And we will start shipping those Simbiza devices from the 25th of May. So if you have any question or feedback, we'll be at the Excel kiosk, the booth, from 12:15, And thank you very much for your attention.
Thanks so much, Adrian, for showing us that demo. I always love to see those real-life use cases, and it's fantastic to see the device working. I hope you all check out the device at the booth and check out the product when it's available. I'll include a link later on for that. So, get back in here. I told you that we were announcing today availability of custom functions in Excel Online, but I haven't shown it to you yet. So here's Excel Online. I just showed you, this is the exact same demo that I showed you previously, and as you'll see, it works in the exact same way. Here I am in OneDrive. I see the nth prime function is available to me here. I reference it inside Excel, hit enter, and there's my result. Copy it down. OK, we are in a preview. Let me try this again. Enter the number at the top. Pick the nth prime function. There's my result in Excel. And now copy this down through the 25th result. And there are my first 25 primes, right in Excel Online. So I hope you all try it out. And let us know what you think. This is the first time that custom functions have ever been available inside Excel Online. Now we're going to explore a little more of the details. Oh, is this not projecting what's on my screen here? Going to get into a bunch of detail around those JavaScript custom functions, exactly how to make them, and what all of the components are. OK, so we're going to see a little bit of code on the screen, but not too much. The two core components that have existed up until today for your Office add-ins are, of course, the manifest file that specifies all the information and metadata that you need about those custom functions, and the HTML web page, where you can optionally specify UI. You don't need to have that UI, but you certainly can. And we are adding to that. You can also include a file with your JavaScript code. This is the function code. It's written in JavaScript. Separate file. This is what runs all the custom functions that I've shown you already today. And in addition, and this is something that was not available before from the preview, you provide with that a JSON file where you show all the metadata that's available for your functions. That includes the parameter names, the names of the functions, the descriptions, all the associated information that Excel needs to know so it can run those functions. Here's a very simple function inside Excel. This is what that function's JavaScript page might look like if you have a super simple function to simply add a number to 42. No sweat. What does the metadata look like for that function? This is what you provide in that JSON file. Also pretty easy. It specifies the name of the function at the top. It's got that description. That description, you might remember, that's what you see in that autocomplete field inside Excel once you start typing it in. The name is what you see in the autocomplete field. The description is what you see when you hover over that field in Excel, and you see more detail about the function. You're also going to specify what type of data the function is using. So in this case, it's going to return a number, and the dimensionality of that data as well. So in this case, it's scalar. That means there's just one value that it returns. But you'll see an example that I'll show you later on where you can return a range as well. The parameters, this is an array, but in this case, you just have one parameter. You can specify as many as you would like. And you give the name of that parameter that gets shown in the IntelliSense for the function, along with a description, and again, the type and the dimensionality. So you could have a function that addresses a large set of data in one parameter if you wish, where the user has to select a range. And finally, we have a set of options that are available to you. And in this case, I have sync set to true. This is the flag that enables that new feature that I've shown you all for our high-performance functions. In order to get them to run in parallel inside Excel and take advantage of Excel's multi-threading recalculation abilities, it's critical that you set that flag sync to true. Okay, if that's false, then it's going to run asynchronously. The final bit of code is in the manifest. This looks like it's pretty complicated and a lot of lines here, but actually there's only 3 bits or 4 bits that you need to worry about. And those are the URLs at the bottom there that specify the JavaScript location, the HTML location, the metadata location, and the namespace for your function. What's the namespace? I haven't talked about that yet. That's where you saw Contoso in my list. So that add-in was able to ship a whole set of functions. And how does the user know that those are all connected, that they're part of the same add-in? That's where you can choose your namespaces. And the namespace that you have will be unique among all other namespaces if you publish to AppSource. That's the store. Internally at your organization, I mentioned the Office 365 deployment. There you can do whatever you'd like with namespaces. That's fine. But on the store, you get to reserve your unique namespace by having an add-in for it. So I'm going to get down into some of the details of how the different function types work. This is a diagram showing the asynchronous functions, right? Those are the ones that return a promise. If you see the diagram, all the way on the left-hand side is Excel. In the middle, there's the JavaScript code running in that JavaScript file that I talked to you about. And then on the right-hand side, perhaps, optionally, you have a server, or you're calling some third-party service, whatever you wish. So you make your call to so Excel makes its call to the developer JavaScript. And then immediately what you need to do is return a promise. Why do you do that? That's the signal to Excel that, yes, you know the function has been invoked, but you're going to send back a result later on after you get it from, say, the web. Okay, so an example of this kind of function is the getWeight function that I showed you for the Contoso chocolate factory. You immediately return a promise. And then when you do that, that's when Excel says getting data. Okay, it shows that getting data error inside the cell, the message inside that cell. And then you can do whatever you want. You can go set a timeout. You can go to your service, whatever you'd like, just locally in JavaScript. It doesn't matter. In this case, goes to the developer server on the screen, and then it returns back the value that you need. And then all you need to do to set that value is to resolve that promise inside Excel. So here's what the code looks like for it. This is the getWeight function. And this one, as I said, just returning the promise. And then it has some call that I haven't implemented on the screen here to retrieve the weight from the server and then set it back into the cell. Really simple. I also showed you an example of a streamed function. Those were the ones that took the weight and continuously updated the value into Excel. Well, how does that work? In this case, you don't send back a promise to show getting data, because if the streaming function, streaming data in, it would just always show getting data every time you enter a result. You don't want that. What you want is just to show the latest value, keep that up to date. And what you need is a callback function that you can keep calling again and again while the function stays live for you to keep streaming in that data. On the server side, you can manage it however you wish. In this example, I have a WebSocket set up. So you could certainly use WebSocket API to stream in data from in your internet-connected device. But you could also use any other methods you wish. HTTP streaming, long polling, individual HTTP calls separated by timeouts on the client side. Really, however you want to manage it, it doesn't matter. It's very flexible on the platform side how those functions work. All you need to do is call the callback that we have to set the result back in. How do you get that callback? It's the caller parameter. Look up at the top line of code there. Stream weight, and then it says scale ID interval and caller. That last parameter is automatically added to any streaming function that you declare. By the way, look at the bottom line of code there. Options, you set stream to true in order to enable this feature in the metadata that I talked about. So when streaming is true, you get that caller. And you see that line in the middle, caller.setResult. OK, so setResult, that's a function. It's a property of the caller object that Excel gives you. You can keep calling that again and again. OK, Excel retains that the information it needs to keep applying the value from that particular caller. It's all running in the same JavaScript context for all your streaming and asynchronous functions. This is another new feature since the preview. It's the ability to cancel your function. This would apply to asynchronous and to streaming functions. It's not something that you trigger. Cancellation is something, of course, that the user triggers. Of course, it happens when they delete a cell. But there are other times cancellation happens as well. It might happen when you change one of the parameters for an existing function, because then the existing set of parameters is no longer valid. For example, say you're getting the stock price of Microsoft, and then you change that cell that says Microsoft to Apple to get the stock price of Apple. Well, if you do that, it's going to send a cancellation request for the Microsoft stock price, and then send a new streaming function request for Apple. And so in order to deal with that cancellation event, you just need to set up a handler. It's very simple. This function up on the screen here is just one that counts up 1, 2, 3, or by whatever increment is specified inside the function, from the user. And you can see, again, using that caller object that's passed as the final parameter in your function, it has an onCanceled property. And I've implemented that to just clear the timer. So it frees up the memory inside your function every time that function is canceled. In order to enable cancellation, you have to set your options for cancelable to be true. That's the bottom line of code that I'm showing up here in that metadata file that you have. And for all streaming functions, they must be cancelable, because it's certainly very common for users to change the cells that they depend on for any given function. Here's another example of, another feature you could take advantage of for the asynchronous functions, which is because there's a single JavaScript context that's made available across all the streaming and asynchronous functions that you have, you can actually share memory across functions. This is really handy for a function like the one that I showed you that streams weight, because let's say you have 100 different instances of that function all requesting the same weight. You don't want to keep going to the server 100 times. You want to just store that value locally. And if your function queries it and it's already available, just pull down the latest one that you have locally without even having to go to the web at all. Very convenient for asynchronous functions. This example is all about working with a range of data. This function is the one to calculate the second highest value in a range. And as you can see, this one takes one parameter, but you could take multiple. And it sets the dimensionality in the last line of that parameter to what's called matrix, which just means that that value is going to be passed as an array of rows. So in this case, you can see it's essentially like a 2D array in JavaScript. Every item in the array is itself a row that you can then iterate through just like any other JavaScript array. I also have a function that can return a range of data as its output. And in this case, it will just return a list of numbers. Here, I have to specify that the results dimensionality is an array, or is a matrix, excuse me. And then again, it's going to require, when I say return output list in the last line of my function, it's going to require that I pass it an array of row arrays in JavaScript. So this is quite intuitive, just what you would expect for dealing with ranges, just using native JavaScript arrays. So I thought I'd take a couple minutes. I haven't talked about the Azure machine learning functions yet, but I will with the time remaining. Please feel welcome to get up and stretch a little during the question break. And let me know if you have questions right now about the JavaScript custom functions. Yes, please, come up to the mic.
Hi, I'm Richard. So we have a COM add-in right now.
Yes.
It's built around UDFs and function arrays.
Yes.
Is there a migration strategy for that? So if we wrote the new one with the Office API, could we not have to rewrite those sheets or recreate those sheets?
So it's questions about migration story for your COM add-in. So the answer is you do have to rewrite it for if you want it to work across platforms in JavaScript. Sorry?
We have to recreate the sheet or the
Could
code?
you repeat that?
Do we have to recreate the sheet? Is that what you're saying?
Oh, do you have to recreate the sheet?
Yeah, so let's say we did write the Office add-in, the newer one with the JavaScript API. Could we somehow get the old sheets from the COM add-in to work?
I understand what you're asking. So the question is about if we have an existing sheet that references a legacy UDF, can that somehow immediately be switched over and migrated to the new JavaScript model?
Yeah, correct.
And the answer is today we don't have a way to do that. But we are exploring ways in the future of having a one-time migration of that sheet to the new, using a tool to the new functions that you want to use. The reason it won't just automatically work is for security, right? So we have code enabled so that it's not possible to hijack another provider's functions. You don't want one legitimate provider published to the store to be using their functions, and then another provider registers for the same name on the store and takes over those functions or is able to see the data that's being passed from those functions. So we're very careful about security of the functions. But the ultimate answer is yes, we'll have a migration story for the sheets. Thank you for the question.
Thank you.
I'll take one more question right now, and then I'll talk about Azure ML functions quickly, and then have another set of questions. Please.
Great. Is this functionality that will be available in non-365 versions of Office?
Question, will it be available in non-Office 365 versions of Office? In other words, if you just buy the inbox software. So to be clear to everyone, of course, it's available across all platforms with Office 365, including the desktop and online and your mobile devices. But, and it will eventually become available in the boxed versions of the software. But it won't be available in the existing boxed version of the software. So in other words, it won't retroactively apply to your Office 2016 inbox software.
OK, so in some future version,
correct.
Possibly. Would you have to install it through a tenant like Office 365, or would you have some other way of installing it to individual users?
If you do not have Office 365, then your options are installing from the store. That still works. Or installing it locally via a sideloading system that we have.
Great. Thank you.
Thank you very much for the question. I want to switch back over to my demo machine to show you, actually, so I don't have 10 minutes left. Let me go to Azure Machine Learning functions. I think the basics of what Azure Machine Learning is It's covered well enough by the other sessions. I really encourage you to check those out. It's becoming increasingly relevant, and especially for Excel. This is just from the Stack Overflow's annual survey. You can see machine learning specialist, highest paid right now for developers in the United States, and Python as super popular language. There's a bunch of different cases today why it's fantastic to get those Azure machine learning capabilities right into your spreadsheets. And here's some examples of them: classifying data that you have, forecasting out trends in the data, a whole bunch of scenarios around analyzing text that exists inside Excel, and then finally picking out errors and issues that are in the spreadsheet. And so I'm just going to show you quickly a couple great examples of what we've enabled there with Azure ML functions, another type of custom function that we expect to be very useful for bringing in machine learning capabilities into the spreadsheet. So let me switch back to Excel. This is the same document that I had before. Once that opens up. What I'm going to show you first is a function that gets that is able to forecast data out into the future. So at the Contoso chocolate factory that I mentioned before, there's a bunch of historical sales data that I have in this sheet. This is showing the revenue that has existed for the past several quarters across many years at Contoso Chocolate Factory. And I have a chart set up to show what that data actually looks like. And it would be fantastic if I could actually predict out, based on historical factors, what that's going to look like in the future. And so helpfully, there's a forecast function that can make that available for me. All I need to do is select that historical data. In this case, certainly you could have other indicators in a real-life use case besides just historical data. But in this example, I'm going to hit Enter here. And then that's going to spit out the predicted data based on that for the future in that orange line you see beside the blue line. You see it did a pretty good job. And there's all kinds of use cases where a forecasting function like this is super helpful inside Excel to have quick access to. What that just did is that went out, instead of using the JavaScript custom functions that I was talking about before, that went out and called an Azure machine learning model that was deployed into Azure, executed in the cloud, and then came back into Excel with these set of results. The second use case I'll talk about here, I have a bunch of tweets about the Contoso Chocolate Factory, or about the chocolates that we produce. And you can see one of the great applications of machine learning today is analyzing text. There is a sentiment function as well. Another example of an Azure machine learning function. I can select the input data here that I'm interested in. And that comes up with a sentiment score in a range from 0 to 1 of the sentiment for the statement. So in this case, the worst one was seriously, at Contoso Chocolate Factory, and then the best one here, well, this is something wonderful. And I've also applied Excel's conditional formatting just manually as a user, not with the function, in order to get those nice colors that we all know and love from Excel's conditional formatting. So those are just a couple quick examples of how useful it can be to integrate Azure ML functions into your add-in as well. This is the same diagram that I showed you previously for the JavaScript custom functions. And instead of shipping instead of shipping a set of JavaScript code with your file, you ship uncode. That one is not packaged. Of course, that one you need to deploy up to the cloud, along with the function metadata, which is again defined with JSON and using the Swagger format. Here's a screenshot. You should all go look at Azure Machine Learning Workbench. It's a fantastic tool that the team has released. Other sessions cover it at build, so I'm not going to go into detail. Essentially, you get a Python notebook type of experience here where the function code can be configured. It also has the capability to let you train your data and let you deploy it. It really is an all-purpose machine learning servicing tool. This is the metadata file, part of the metadata file for the function that I showed you. So you can see it's Swagger, and it'll take a set of inputs specified in that metadata, which are then converted to parameters inside Excel. So in this case, the parameter for the revenue history function is just one revenue history parameter, and it takes a whole bunch of data at once. But you could set up selecting multiple columns as separate parameters for your function if you wish. There's also a great tool as an alternative to Azure Machine Learning Workbench. If you don't want to write a lot of code, there's Azure Machine Learning Studio, where you could just drag and drop a lot of existing pre-built components to create fantastic ML functions. These are the steps to deploy a function, build and deploy using Azure Machine Learning. I mentioned training. You could upload your data set and deploy that model. And then to actually get that add-in into the user's hands, it's just the same as any other add-in, easy to deploy to an organization, like I mentioned. So I should mention that the Azure Machine Learning functions, not available for you to try today in the preview. The preview is for the JavaScript custom functions, and I will give you more information in the future about that. So thank you all for coming to the talk. I hope you go and try custom functions, aka.ms/custom functions. Thank you. Got a couple minutes for questions now, and then afterwards I'll be at the add-ins booth. I'll hang around here for a few minutes, and then I'll go to the add-ins booth at the expo, and please come and stop by. Please.
Hi. I end up having to use Excel as a calculation engine a lot, and right now we're having to jump through a lot of hoops to get it to work as a automated calc engine on servers.
Sorry, could you repeat or talk a little closer into the mic?
Sorry. We end up using Excel as a calculation engine.
Yes.
And we have to run it as an automated calculation engine on a server for a lot of the Excel templates that our actuaries set up for them to use. The unattended feature that you're talking about, is this going to be the holy grail sort of option that gets rid of all these hoops that we have to jump through to get that to work?
OK, so the question, which I love, is whether the unattended use case that I talked about is the holy grail for custom functions. So that depends on your exact use case, what the holy grail is. But to explain what it does, essentially, once you deploy that function and add it to the spreadsheet, if the user has permissions to use the function, then it's going to run without anyone looking at the spreadsheet. Okay, so first of all, someone has to have permissions to use it. If you're making a graph API call or somehow changing the data inside that file and it's uploaded to OneDrive, then that function is going to be able to run with no one looking at it. Is that the use case you were looking at?
Sort of. We have Excel installed on servers and running in an automated way, which I know you're not supposed to do. Microsoft doesn't support that.
Oh, is this an on-premise?
Yes.
Server,
so Excel's running a lot of calculations, and we have to be able to call that remotely to get that to run.
I understand. So if you're using Office 365, I think it is the holy grail. If you're running an on-premise server, we do not have a plan right now to get those running. Thank you for the question, though. All right, I think I'm out of time. I'll hang around in this area to answer some more questions. Thanks, everyone.